just a quick glimpse, but there's the first page is matching. So all these words on the left and all these definitions, kind of definitions on the right. So the other 3 pages are some drawings, as you can probably imagine. 1 or 2 questions that kind of ask, kind of what you know about this, and then there's the math stuff. I was looking at, just because Ben wanted one so badly, I was looking at doing one where you had to figure out the temperature, and I thought, no, that's just not fair. So I changed it. Anyways, blah, 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 according to me. What do you
I have
guys
a question.
Yep, go for it.
So Wednesday, we're not like
In the building.
We're going remote.
You're not in the building. Wednesday or tomorrow in math, which is kind of a study day, we'll talk about how we want to kind of proceed. Because physics, you have a test, so we'll just write the test. But I'll see everybody again in pre-cal, and then we'll kind of talk some pros and cons and things like that. So what I mentioned in the seems weird. I'm just talking when there's just a blank piece of paper. What I mentioned in pre-cal earlier is that our test in pre-cal is supposed to be Thursday, but our schedule for remote learning has pre-cal Monday and Wednesday. So theoretically, we should have the test Wednesday, but I don't think that's fair to you guys. So we'll talk about it tomorrow. We'll figure out what's going on. Other questions?
So would physics be Tuesday, Thursday then? So we wouldn't have on Wednesday this week?
Correct.
Wait,
Okay.
so we only have like a couple subjects per day? Like they don't overlap?
What do you mean by they don't overlap?
Like what do you mean by we don't have physics and pre-cal on the same day? Like what does that mean?
So it's the schedule that we used in the beginning of January, and I think maybe the beginning of the school year. I honestly, everything's a blur right now. But generally speaking, I was going to show you guys, I was going to take kind of a screenshot, but I think they're tweaking, so I don't want to mess with anything. But I think the way it's going to be, Monday and Wednesday is pre-cal from 1 to 2. Tuesday and Thursday is physics from 1 to 2. The alternating days, it's kind of between 11 and 12, like open office hours. So it's no new lessons or teaching. Those Monday, Wednesday for pre-cal, Tuesday, Thursday for physics is required attendance. Like you need to kind of show up on Zoom, and I didn't need to take attendance. We do a lesson, blah, blah, blah. But we're having half the class time that we've had so far.
So it's not like we're gonna, like on the days that we don't have pre-cal or don't have physics, we're still getting lessons, but just not the Zooms?
Nope, you're not even getting
We're
lessons.
not getting anything?
Not from me. There will be other subjects and things. One of the things I mentioned in the earlier class is that what I will probably do though is I will record lessons of units that we're just not going to get to for pre-cal, and those are optional. And so people going on into pre-cal next year are encouraged to do them, look at them, consider them, just to kind of help with the transition next year. But it's not going to be required. It won't be marking it or anything. Like we're going to slow down. When we went to remote last year, kind of in spring or whatever, we didn't slow down, or most teachers didn't. And then it just got to be too much, and lots of complaints, parents and students, and
Yeah, it felt like it was a lot more.
Yeah, and I think teachers were probably kind of overdoing it, just trying to make up for whatever,
Mm-hmm.
It's definitely going to slow down. Physics will slow down. You'll have 2 lessons a week. So who knows, maybe for the easier lessons, I'll double up a little bit, but I'm not going to try and jam things full, and it just kind of is what it is. So does that kind of make sense right now?
Yeah.
It's crazy times. Sucks. And I don't even think kids will be able to come in if they want to. It'll have to be all Zoom for like extra meetings and conversations about whatever.
I mean, it's nice that we'll not have a lot of work, but it's also kind of sad that we're not going to get through stuff. Like,
Yeah, Yeah, there's the pros and cons. Yeah, you won't be slammed, but it's like, oh, okay, but what am I missing? What am I missing? And then I'll have to try and figure out what I'm gonna do. I haven't even looked at it yet. I've just been trying to, whatever, do other stuff. That'll be my afternoon. I'll be starting that process. I was gonna say something else. Yeah, and who knows? Like this goes till May 30th, and at that point it could be extended. I might have seen you guys in person. Oh, I guess it'd be tomorrow. Tomorrow might be the last time I see you guys in person. It might be the last time I see you ever. Not to get, you know, whatever the word is, melancholy or.
That's sad.
Yep. So, yeah, man, that's the world we live in right now. That's the Winnipeg we live in.
We'll make sure to visit you at your other school.
Yeah.
Show up.
Yeah. I'm hoping I get another school. I was just thinking about that. I don't have a job yet, so hopefully. Anywho, well, who knows? Maybe I'll be subbing here next year. I hope not.
I hope so.
Not because there's anything wrong with this place, but it'll mean I don't have a job. So, but
Yeah.
I'll probably be tutoring. So if anybody needs tutors, then. Anyways, physics. Are there questions? No? Okay, bye.
Yeah, for the notes, it says when there's, for the media boundaries, it
Yeah.
says that it's not fixed or free.
Yeah.
It says that the reflected wave would remain upright if the second medium is slower, and it would be inverted if it's faster. So what would a faster or slower medium be?
More dense. More dense.
More dense would be faster?
Yeah.
Okay,
Think
a wave can go
sound
through.
traveling through, like sound, the vibrations travel through stone, travel across the water, much quicker than through air.
Okay. And then if it says the difference in the medium is greater, the majority of the wave is reflected, or smaller, the majority of the wave is transmitted. So what would a difference in medium be that's greater or smaller?
Would it help if I say I've removed tricky questions like that from the test?
Yeah, but I still want to know.
So when it's talking about the greater the difference, so I want to see the diagram. Do you have the diagram in front of you? Oh wait, I'm just about there. Okay, so when it's talking about greater the difference, it's focused mostly on the density of the medium, like the density difference. Because if it's just a real subtle difference, then you can kind of treat it as the same medium. But as far as like we're concerned with the textbook, there isn't any kind of specific number. That happens in grade 12 when you to kind of compare the densities, but it'll be more kind of coming from, it'll be refracted light going through like layers of like water and oil and glass. Like, the way something looks in a swimming pool or glass of water, your straw is all different.
Yeah.
There's going to be formulas to work with that. We don't worry about that here. This is more of an introduction to the idea.
Okay.
Wait, so this is like referring to like if a rope was like attached to a string and then you like sent a wave through it.
Yep.
But if this like the string or whatever, the thin one was on the end of the rope, I'd assume it would like have a higher amplitude and like the wave would have a higher amplitude, but it's not. It's
Yeah.
the opposite?
No, you're right. It's the energy, right? It's how the energy, if you think of how much, again, this is why there's not a whole lot of math associated with it, because there's so many variables. But if you think of me, I can lift on this desk with my shirt. I can lift on this desk with 25 newtons. It doesn't do anything. If I lift on this bottle with 25 newtons, it goes up. So it's how the energy is transferred. That amount of energy will do more depending on what you're dealing with.
So, but something less dense will have more of a reaction with the same amount of energy.
Yes. Here's one way to think of it. I had this old roommate, whatever, he's my age. We don't live together anymore. Brent had this mountain bike that he rode very infrequently. And it had these crazy shocks on the forks in the front and in the back. They weren't shocks, they were springs, like you could see them. And when he was riding, he would be kind of like bouncing, like just over little bumps. It was the silliest. It was like this man on a child's toy. It's not efficient. Like all this energy is being wasted, in all the bouncing. And so it's where the energy has to go. So like in a light string, like, yeah, it'll go higher and stuff, but then it'll dissipate because of damping. Damping, you'll need to know. Thoughts? Comments, questions? Furniture moving?
Oh, that's mom.
Oh, way to go, Mom. Don't say that. Don't repeat that.
Mom, I'm on a Zoom.
It wasn't really loud. I'm just bugging. Other questions, thoughts? Ada, is Maya somewhere there?
I think she just left for work.
Okay, well, tell her, I'll see her, if I see her tomorrow, tell her that my family says those are the best cinnamon buns they've ever had in their life. Like,
Oh, really? It's a family recipe.
well,
We made like 24 dozen.
yikes. Well, they
It was
won't.
insane.
They're good. They're very good.
Thanks.
Other physics-related questions or remote learning, or I don't know.
I think I have some questions.
Well, I've got some questions from Kate here. Let me write this down. Hang on. Page 445, 48, 50, 55, 58. Anybody else while I'm writing stuff down?
I was wondering if we needed to know about like the guitar tuning and like stuff about that.
Um,
The beats and like how much you need to tighten it for it to be.
Not specifics, but generalities. Like when you say how much you need to tighten, like we're not measuring, linear density or anything like that. But the idea as to why, yes.
Okay.
Other questions? Okay, so Kate, I'm gonna look at these quick. Number 48, don't worry about. I'm taking away kind of the trickier, harder stuff. Number 50, blow over the oven, the sound that's produced. If you add some water in the container, repeat the procedure. How would the frequency you would hear change? Okay, so 50, you're blowing over like you're making that whoo kind of a sound through an empty bottle container. And then you increase, you take up space. So you're shortening the length. When it talks about the length of the medium, you're shortening the length. And so let me just write the formula down. Where is it? So Ln equals 2n minus 1 over 4. So let me go back to the question, which was number 50. How would the frequency change? You could put in, this is one of those questions where you've had them before. I'm trying to think of like the style of question. But basically, if everything here is the same, but something gets shorter, then you figure out what effect that would have on something else. So in this case, what effect would that have on the wavelength? And then you'd put it into, these are normally switched around. You put it into this equation and see how the frequency would change, because that's what it's asking right now, is how the frequency would change. So it's a matter of just kind of putting it in and then seeing what would happen. I'm trying to think, like, I can't think of examples right now, but there were ones I know where it's like F equals 1 over wavelength. So if the frequency gets bigger, and sometimes we get hung up because we don't know what these numbers are, we'll just put a number in. Just put a number in. So if the frequency is 2, for this example, 2 equals 1 over, what would this have to be? This would have to be 0.5. But then if the frequency was cut in half, if this was changed to 1, then the wavelength would double. so that it would make sense. It's one of those situations for question 50 where you just have to put some numbers in and see how it would change things. For number 55, let me have a look at that. By the way, that question number 50, those kind of open-ended, that type of thing, you're not going to get that either. It might help with your understanding, but you're not going to get that. 55, goodness gracious heavens to Murgatroyd. This question is a little bit ridiculous. I think somebody asked in class. What you would need to do is kind of trace this. You take some kind of thin piece of paper, trace the first one, and then try and trace the second one over it. And then you're looking for all the points where they line up and things like that. I'm not giving that to you. You're going to get what happens when this meets this. And these will be exactly the same width. You know what I mean? You'll get these types of questions. Number 58. Pilots refer to the speeds in terms of the Mach number. When a jet reaches Mach speed, we hear a sonic boom. Draw a sound wave diagram for the following scenario. Jet flying to the right. The speed slower than speed. How does the distance between consecutive rings look on the right side of your diagram? Okay, this is, the Doppler effect. So this is your airplane. You probably just wanted me to draw, which is very mean of you. What does an airplane wing look like? Not like that. What the heck is this? A Play-Doh plane. I don't know how to draw, okay? So it's a plane that looks like a rocket, and I suppose this other wing is supposed to look the same. Oh, well, at least you know what that's supposed to be. So when it's moving, if it's just kind of right there and it's emitting sounds, I'll do it in pencil really lightly, then there are these circles, kind of like waves in a pool. Okay, like waves in a pond. They're just kind of equidistant, they spread out. Well, when this bad boy is going this way, the rings get tighter over here. So it'll be kind of like tighter there, but more space in the back. Tighter here, but more space in the back. That kind of thing. It squeezes those. I don't know why I'm drawing this. I could have probably just looked up a diagram to show you kind of what it's what it's getting. Oh, here we go. This is much better. See, as it's moving to the right, it compresses those sound waves. Even if you're swimming, if you're just kind of treading water in one spot, right here, the waves will kind of dissipate away from you equally. If you are swimming this way, the waves behind will have a lot more space between them. The waves in front, they'll bunch up a little bit. Back to the rest of the question. How does the distance between consecutive rings look? Okay. Draw the same diagram with the jet moving at the speed of sound. Well, the speed of sound is trickier because now I'm going to do this way simpler. Because with the speed of sound, these are sound waves right here. They can't get in front of the airplane. So it's like if this is your airplane, I'll make it more hot dog shaped. This is your airplane. Those rings are all going to be like right there, but then like they do this kind of behind, but they're all right there because they can't move away from this. They aren't fast enough. I hope that kind of makes sense.
So in general, like a shorter wavelength equals a higher frequency. Why? Like without like the picture and diagram, like I get it in that respect, but like I don't understand why.
Mathematically, if the speed,
Okay.
Does that make sense? If the speed is whatever, just 10, and the wavelength is 2, frequency has to be 5. If the wavelength goes up, let's say it's 10, well then the frequency has to be 1, provided speed stays the same.
Okay.
Kate, was that okay for you, those questions? Look at all this drawing. Ada, do you want me to keep this for you so you could take some tips on how to do art?
No, thanks. I'll pass.
Tips? Tips on how to do art. I can't even talk like a human when I'm talking about it. Making, creating. Do you need? Sorry, what? Someone's trying to ask.
Could you do D from the same question?
Sorry, what?
Could you do D from that same question?
From 58. Use your diagram from C and your knowledge of constructive interference to describe why a sonic boom is heard. It's okay. Is there a picture? Like, there's probably a picture. If there isn't, then you guys have probably seen it. Sonic boom, you know that crack that you hear like when a whip cracks? That's the tip of the whip breaking the sound barrier. Hang on, just looking to see if, I thought there was a picture here. Oh, there it is. That's what I want. That's what I want. Okay, so here's this. This is an assignment we would have done in normal days. And then most people complain about these assignments that I used to give. So look at this bad boy. Like, what a cool picture. This is vapor in the air. So the sound, you know, is energy moving through the air. This is so much. I'm gonna show me here, see if it helps. If I'm kind of moving, if I'm something that's moving towards the speed of sound, all this air gets kind of built up in front of me. It's like if you're going through water really fast, the waves will create bigger waves as they separate and kind of move away and leave bigger wakes. You see that if you've ever seen any of these videos when a big chunk of an ice shelf falls off and creates an iceberg. There's just tons of water, just these huge waves that come. So what happens here with this vapor cloud is because air has humidity, holds some moisture, you know, relative humidity, the term's relative humidity, it means relative to the temperature. Warmer temperatures, air that's warmer can hold more water. Cooler, it can't hold as much. So anyways, this, I think I'm gonna sneeze. You have this moisture in the air and then all these waves are compressing it. They're pushing the air against each other. And that's why this kind of cloud happens. And that sonic boom is, you know what? There's a probably better description than me just saying it. No, it's not there. Let me see exactly what the question was asking. Oh, I didn't save it. Did I write it down? I did. 445.
Something breaking the sound barrier is something moving faster than the speed of sound.
Yep. And so, page 58. Do you use your diagram and your knowledge of constructive interference to describe why a sonic boom is heard? Oh yeah, no. How would you answer that concisely? Constructive interference. So these waves, you keep pushing. So the amplitude, you know, of the sound waves gets so high, and it must just be. I don't know the exact answer to that, but it must just be. It's like a release. You know, that energy, that pent up energy, has to go somewhere. I'm gonna look it up. And then I'm gonna attach a. This is nowhere near some kind of a test question, because it's saying to you, why do you think? So I'm gonna look it up and give you a good answer because I can't remember.
Okay.
Yeah, I want to know too. I think I used to know this and now I'm forgetting. Ask me questions I know the answer to. Any other questions that I can't answer? I will be able to answer the ones that will be on the test tomorrow. Anybody else? Do you guys hear that? The dryer's done. Oh. So what is on the test? Just simple question. This is what's on the test. You ready? Here we go. So you're gonna do some matching. Choose the best answer. There's 20 terms. I shouldn't do that because you guys can pause the recording. Well, anybody can do it now. Don't cheat. I told you you're gonna add some waveforms together. You should have an idea of the harmonics, antinodes, how those are related, fundamental frequency. I see you, Kate. And math. Oh, tuning, you asked Ada, tuning a guitar, for example, what that has to do with beats. Damping, I mentioned that, and then the Doppler effect. Some math on the Doppler effect. Can you dig it? I'm so curious when I'm done recording this. I'm gonna go back and see if I can see that page clearly.
I don't think the recording is clear enough. They're
I don't
usually
think so
a bit
either.
blurry.
I don't think so either, but I'm curious. Everybody will get the same thing, so I suppose that's fair. I hate this. I hate this remote stuff. I hate this pandemic stuff. I feel like I want to make your guys' jobs a little bit easier, but not take the, you know, the meat of it away. You still need to know your stuff. So, other questions?
I'm trying to find a question that I had.
Nathan's good.
Okay, I'm confused at this one. I don't know if it's like in the notes somewhere or if I just can't find it. Page 443, number 15 says when an ocean wave appears twice as large as it should be and is not the result of seismic activity, what is it called?
It's interesting because it has in there. Oh, I guess I was just looking at kind of this multiple choice, and it has the 9.6 beside D, the answer, and not beside any of the other.
Oh,
That's not a question that you would get. I don't know what a rolling or a random wave is. A rogue wave is just fluke of superposition, of constructive interference. It's just like that one question that Kate had mentioned, like where you're comparing this waveform with this waveform. Well, you wouldn't be asked that. That's crazy. But that's what's going on in the ocean. There's waves, and and some come from different things, and because of wind and whatever. And every once in a while, like two will just like get together, and it's just a rogue wave where all of a sudden, like the highest waves that we're seeing, oh wow, that wave is 20 feet high, and then out of the blue, just because of constructive interference, you've got a 40-foot high wave. And it's out of the blue, like nothing changed. The wind didn't change or anything. It's just the way they happen to kind of combine in that one moment. That's a rogue wave.
and I also,
question.
okay, I also don't understand, like principle of superposition and constructive interference are the same almost, right?
Almost.
Like what's the difference?
Constructive interference, they combine to get bigger, not to the max possible. That's the principle of superposition.
Oh, because that could be negative.
Yes, the
The
principle
max.
position, yeah, it could be down. Yeah, and constructive just means they get a little bit. They constructively interfere, so they can get a little bit bigger, but don't necessarily line up perfectly to kind of double their amplitudes.
But it says the resulting amplitude. Okay, yeah, it says the resulting amplitude has to be greater than either. But I guess that means like it doesn't have to be both amplitudes combined perfectly.
Exactly. Yeah.
Okay, I see.
Other questions?
I don't think so. Not for me.
Well, I'm here all day, and I'll be here tomorrow if questions come between now and then.
I think I had a. Sorry.
Let's just see if Kate was good, but go ahead.
I have a question for pre-cal if Kate is done.
Kate, good sister? You can, Kate, you can hang around, but I'm gonna end the recording because of physics. Okay, I'm assuming things are good, although I know her Wi-Fi can be a bit sketchy. Yeah, she's good, all right. Oops, I don't mean to end the meeting, I wanna end the recording.